Hello, everyone. This is Eileen Kladivko, a professor in the agronomy department at Purdue, and I'm going to talk to you today a little bit about drainage for the long haul, key takeaways from our long-term SEPAC study. As you all know, naturally poorly drained soils give us many challenges for crop production, and subsurface or tile drainage is a common water management practice that's used for crop production throughout the Midwest. So I'm going to talk today about a project that has been conducted in southeastern Indiana in Jennings County at the Southeast Purdue Agricultural Center, a long-term tile drainage research experiment that some of you have heard some things about before at our meetings in the past. I'm going to present some of the results in kind of headline form, and the first one is that drainage pays. I'm sure many of you already know that, and others of you will be very happy to hear that we have some additional long-term data to help support that, that result. So drainage improves timeliness of field work. During the first 10 years of our long-term project, different drain spacings were chiseled and planted when the soil was ready. So we were using tillage, and when each drain spacing was ready, it got tilled and planted. The undrained control plots were delayed anywhere between 1 to 15 days, depending on the year, compared to the narrowest drain spacing. So this kind of more timely access to a field is really a major benefit to most farming operations. You can see evidence of that from this photo, which was taken in February. But what I want to point out here is that the drain lines are superimposed on this image. You can see that the lighter colored soil, where the soil is drying more quickly, is where the tile drains are. And you can see here the dark soil, which is indicating that the soil is not drying as quickly, are our undrained controls in this tile spacing plot. So very evident, very obvious that the soils drain quicker where you have drains. Drainage pays. Drainage improves crop yields. Most of you have not, none of you have seen this data from the entire project period. So from 1984 to 2017, during that time period, we had 24 years of corn, and the 40-meter or undrained control plot averaged 144 bushels per acre over that entire time period. And then as we started draining the plots, we got yields in the 160s, and the narrowest drain spacing, 5 meters, was 168 bushels. So 24 bushels per acre on average yield benefit compared to the undrained control when looking at this 35-year project. If we want to go into a little more detail, some of you have seen this before. This was from the first 10 years of the study, looking at the yields with each drain spacing and the average. The average over 10 years was 10 bushel per acre difference between the undrained control on the right here and the narrowest drain spacing on the left. That 10 bushels was less than we had anticipated, and I'll talk more about that later, but you can see that those yield effects obviously vary from year to year. In some years, the narrowest drain spacing has the highest yield. In other years, the intermediate spacings have the highest yield. The undrained control, or the light blue on the right here, 7 out of the 10 years was the lowest yielding. And again, on average, a 10 bushel yield difference. As we went further on in the experiment, we got some wetter years. And so if we look at the last 10 years of the experiment, in the years where we grew corn, where there are bars missing here, it's because we were growing soybeans. And you can see that in some years, there wasn't too much difference between the drain spacings and the undrained control, like 2007 and 2011, for example. But in other years, you can see huge differences, especially with the undrained control, being much less yielding than the drained spacings, 50 bushels or more difference between the undrained control and the 3 drain spacings, which is obviously a huge difference as far as the farmer is concerned. And of course, these are wetter years, and a drainage is a long-term installation, and that's why we need to look at the entire time period. But you can see that in some years, it's a huge benefit. Another aspect of timeliness to consider is replanting. In the 1994 to 2017 time period, all plots were planted the same day because we had switched to no-till, so we no longer needed to wait until the top 6 to 8 inches were suitable for tillage. Just had to wait for the top 1 to 2 inches to be suitable for seeding. So everything was planted on the same day. But of course, if it continued to be wet after planting in the extremes, then we may need replanting for the undrained plots. So in 2017, that's exactly what happened. The field was planted on May 16th, but the undrained control here didn't make it. It was too wet, and so it needed to be replanted. So it was replanted 2 weeks later on June 2nd, and this picture was taken 10 days after that. And you can see here in the center, this is the undrained control. There's no corn stand remaining from the original planting, whereas on either side, to the left and right of that plot here, you can see that corn was growing well from the original planting date. So obviously timeliness can be looked at from the original planting, but also from the replanting possibility. None of you have seen this, these data presented this way. So this is the corn yields over the entire project period. And you can see that the moving average line is bouncing around, as you expect, based on weather and so on. But if we take a look at a linear trend line, which has a lot of noise around it, but a linear trend line for the 5 meter, this dashed turquoise, dark turquoise line here, we can see that that linear trend is giving us about 1.9 bushels per acre per year increase in corn yield over the length of this time period, which is essentially the same as what we look at for national improvements in corn yields based on primarily genetics, but also on technology. So 1.9 bushel per acre per year increase where we have drainage. This light blue color dash line, however, is the undrained control, and it's actually decreasing a little bit, or basically flat. So if we want to get the benefits of our improved genetics and our improved technology, we have to have drainage if we've got naturally poorly drained soils. Drainage pays. Let's take a look at a different aspect of that. Drainage improves cover crop growth. This was from 2016, one example. But in this particular year, we were going to be growing soybeans, and it was wet, so we had not gotten the cover crop terminated earlier. So on May 13th, the day that we were going to sample and then terminate the cover crop, you can see we've got really good growth, about 3,100 pounds of biomass per acre in the tiled plots. In the untiled plots, however, you can see here very poor growth, looks really puny. We had less than a fourth of the growth that we had in the tiled. So again, if you're going to go to the trouble to plant cover crops, you're doing it for a reason, whether that's to improve soil health or to scavenge soil nitrate. And so you want to have enough growth to make it worthwhile. I'm going to briefly talk about the other drainage experiment that we had on the field for the first 9 years. You usually hear me talk about the 4 drain spacings, but we had another experiment where we had subsurface tile drainage versus no tile drainage, so 2 different subfields. All of the plots were split, chisel versus no-till. And then the treatments were 5 different agronomic practices. Our purpose here was to try to look at improving soil properties with and without drainage, and how much synergy would there be by having drainage along with the various conservation practices. So our base or our control was continuous corn. So CC here is continuous corn, not cover crop. And then we looked at either a winter cover of wheat or cereal rye with the continuous corn, a winter cover of annual ryegrass with continuous corn, a dry manure application in the spring with continuous corn, or a rotation, a 3-year rotation of corn, wheat, and then an orchard grass, red clover, meadow. And the covers in this case were hand broadcast into standing corn each autumn. So what I'm presenting here are the corn grain yields and the percent increase for tiling. So this was a 9-year experiment done from 85 to 93. So the blue bars are tiled, the red bars are untiled. So you can see here that for continuous corn, there was a 12% yield benefit to tiling compared to untiling. But where we had other conservation practices, there was about a 20% yield increase for the tiled compared to the untiled. Another way to look at it would be to look at the continuous corn control and then look at our conservation practices. And you could see that our yields were equal or greater with conservation practices where we had tile. On the other hand, where we did not have tile, the conservation practices were equal or lower yielding than the continuous corn. So our main point here is that drainage enables other conservation practices to work better. So if you have a naturally poorly drained soil, conservation practices such as no-till or cover crops or a rotation with hay crops are going to be more effective in increasing crop yields and improving soil physical properties in tiled versus untiled fields. I didn't have a chance to talk about the soil physical properties, but we measured aggregation and infiltration, and that also got improved better where we had drainage than where we did not. So adequate drainage really is a necessary first step to improving crop yields and soil health. Okay, the third topic really is our water flow and water quality. So the first point is that closer drain spacings lose more water and nitrate in tile drain flow. We're looking here at the first 3 years of our experiment. And of course, we put tile drains, when we put tile drains closer together, we do it for the purpose of removing more water faster. And so that's what happens. And if we remove more water faster, that means we also remove more nitrate because it's just flowing with the water. So in this early time period where we were using high fertilizer rates and did not have a cover crop and we're growing continuous corn, our 20-meter spacing lost on average 23 pounds of nitrogen per acre per year coming out of the drain pipe. And as we brought those drains closer and closer together, our nitrate losses increased. And if you were at the 5-meter spacing, we were losing on average 44 pounds of nitrogen per acre per year, which is a lot. It was high. It was typical for the time period. The good news is that when we incorporated cover crops into the system, we reduced those nitrogen concentrations. They were reduced by 2 main changes that we did. We integrated cover crops into the system, and we went from a continuous corn system to a corn-soybean rotation, which means we could lower fertilizer rates because of the soybean credit. So you could see much lower losses during the late 90s, still have a bit of that stair-step effect, where we increase losses as we increase drainage because we increase flow. The not great news is that even with those same low concentrations, during the next 15-year period, 2000 to 2015, we actually had more rain, about 5 inches more rain per year, most of which came during the winter, which means most of that was drainage. So again, our loads did increase, although we're still at the same low concentration. And again, tiles closer together lose more water and lose more nitrogen. So a couple of wrap-up slides. Drainage is, of course, a long-term investment. Drain flow develops over time. Yield effects vary from year to year. Some years there's not much impact of drainage. Other years there's a tremendous impact. Conservation practices take time to improve soil health, but the long-term improvement in cash crop yields and cover crop growth and the effectiveness of other conservation practices make tile drains a good investment. So, would you like to know more? If so, you can watch parts 1, 2, and 3 videos where I go into more detail about each of these 3 topics that I've just talked about. And you can find that on my drainage webpage. Or you can read extension publications on these same 3 topics that are in the final stages of finishing by Ag Communications. And you can get them at the Purdue Education Store or on my website, and these are nearly done, and these will be posted and uploaded to the web by mid-June. So with that, I would like to thank you